In this lecture, we shall discuss some problems on gravitation, and the problems are chosen from various competitive examinations of repute. The level of the questions, the difficulty level, will vary from one problem to another, as we shall see in due course. So here is the first problem coming on your screen, and this one is telling that three particles, each of mass m, are located at the vertices of an equilateral triangle of side A. The only forces acting on the particles are their mutual gravitational forces. It is desired that each particle moves in a circle while maintaining the original separation A. Find the initial velocity which must be imparted to each particle and also the time period of this circular motion. So first of all, let's draw a figure to understand the situation of the problem and recognize the circular path that must be followed by each particle. So here is an equilateral triangle of side length A each. Let me name this triangle as ABC for convenience, and three particles of mass small m each are placed at these three vertices. So I call the particles 1, 2 and 3 for quick reference, and let me write as well the mass of each of them is m only. So since they are talking about a circular motion for each particle without changing the separation from other particles, let us try to recognize that circular path. We focus on one particle because since all three particles have the same mass and their separation is also the same, any of these three particles is representative of the other two particles. On particle 1, both particle 2 and 3 are exerting gravitational pull along the lines AB and AC respectively. So if I could show these forces, these are the forces named F12, that is the force on 1 by 2 and the force on 1 by 3. We shall show that these two forces have the same magnitude, and therefore by parallelogram law the resultant of these two forces, that is the net force acting on particle 1, that's acting along the median drawn to the vertex A. Similarly, you can show for this particle 2, the net force acting on it exerted by 1 and 3 together, that will be acting along the bisector of this angle ABC, that is along the median through the point B, and the net force acting on the particle 3 will be acting along the median through this point C. So therefore, if I could have drawn those medians through A, B and C, we argue by the symmetry of the situation that all three particles must move in a circle whose center coincides with the meeting point of these three medians, that is the centroid of this triangle. And if these three particles have to travel about a circle with its center at centroid G without changing the mutual separation A, the circle must pass through these three vertices A, B and C with its center at G. In other words, the circle of motion becomes the circumcircle of this triangle ABC. Once we understand this, we have got two jobs in hand. First, to find out the net force in magnitude acting on any of the three particles and the radius AG of the circle described by any of these three particles. We shall write the equation of motion in the radial direction for any of the particles, apply Newton's second law, and from there we expect to get the linear speed of motion, circular motion of these particles. So that is the approach towards the problem. As my first step, let us concentrate on this particle 1. I have already said whatever I show for one particle, that's valid for other two particles also, because these three particles are completely equivalent in my given situation. We see that these forces F12 and F13, they have the same magnitude. So let me call that magnitude to be F, and this is given by the law of gravitation, capital G gravitational constant into mass of each of the pair of interacting particles, m into m, divided by square of separation between the particles, either the length AB or the length AC, that is coming out to be A only. So therefore, I get the magnitude of the force is G into m square by S square. We have already seen these two forces have the same magnitude. It means that the resultant I might call F net, the net force acting on particle 1. This is acting to the bisector of this angle BAC. This F net is acting along the bisector of this angle BAC, which means that this angle is 30 degree as well as this angle is 30 degree. This is along the median. This is AD. Let me call this foot as AD, along the line AD. And the magnitude of F net, this can be found out by applying parallelogram law. You remember that square root of P square plus Q square plus 2PQ cos theta. In this case, I might write down magnitude of F12 squared plus magnitude of force 13 squared plus twice F12 into F13 into cosine of the angle between these two vectors, which is the angle 60 degree. In equilateral triangle, all three angles are 60 degree each, so cos 60. And then noting that F12 and F13 have the same magnitude of F, I am writing it to be F square plus F square plus twice into F square into cos 60, that is half only. So 2 and half cancelling out is giving me root 3 into F. Putting the value of F from here, I am getting the net force has a magnitude of root 3 G into m square by S square. So this is the magnitude of net force acting on any of these three particles, that is root 3 G m square by S square, acting along the median towards the centroid G, which happens to be the center of the circle described by any of these three particles. Once we get the value of F net, let us now also find out the radius of this circle described by this particle. That is, radius means this length AG or BG or CG, is not it? And you know that at the centroid, the three medians get trisected. The ratio is 2:1, AG is to GD is 2:1. So, let me find quickly this length AG.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.